we're going to get started here with our next session on IIIF, from images to multimodal corpora annotations. And I'm delighted you have the bios online for the full version. So everyone is incredibly accomplished, and I encourage you to read them and all the amazing fields and places and institutions that folks are coming from. So we will get started here with Régis Robineau from Bellissima and the campus Condorcet. Thanks for letting me butcher French for the next hour and a half. So I'll turn it over to you.
Thank you very much. So first, I'd like to thank the organizers for the invitation, and I'm happy to present you today what will hopefully serve as a useful introduction to this session and try to give you a common understanding of what is IIIF and what are the benefits and prospects of these standards. So IIIF stands for the International Image Interoperability Framework, and concretely it is both a model for presenting and annotating digital content, so digitized or born digital materials, specifically images and audiovisual files. And it's also a global community of people and institutions working together trying to solve interoperability challenges by developing open APIs and software tools that implement those APIs, and by exposing compatible digital content on the web. This community is lively and welcoming, as you can see in this picture from the last IIIF pre-pandemic in-person conference in Göttingen, Germany. And this community is currently composed of hundreds of institutional adopters and participants across the globe, with libraries, archives, museums, universities, research institutions, aggregators, etc. Here is an overview of the different components of the IIIF community as it is now, with the different working groups and stakeholders, and all of this being coordinated and supported financially by a consortium of 67 institutions. So the main goal of IIIF can be summarized like this. The aim is to create a global framework by which image-based and time-based resources can be delivered in a standard way from any participating institution for display, manipulation, annotation in any compatible application for any user on the web. So from a technical standpoint, the general idea of IIIF is to go from this, that is to say, a world of silos and duplication, with no capability to share functionalities and data between systems, and across institutional boundaries, where content providers keep trying to solve the same problems on their own, and in some way reinventing the wheel in their own software stack. So the idea is to go from this to that, that is to say, a distributed environment and where a wide range of digital tools and software can interact with content repositories based on a common interoperability layer provided by the IIIF APIs in the middle. So in this kind of environment, every repository can become a remote endpoint for third-party applications and allow them to display, manipulate, annotate image and audio and video content. For instance, application A could be an image viewer or a comparison tool. App B can be a transcription or annotation platform. App C can be a content management system to create digital exhibitions, for example. Or we can also imagine a virtual library of dispersed objects or collections of objects, a curated set of materials for research and teaching, etc., etc. In fact, it could be any kind of application making use of those digital assets available via IIIF. So now let's explore a few examples of tools and platforms which illustrate the variety of things you can do with IIIF. First, you can zoom in high-resolution images and compare them. For instance, the different spectra of a painting. You can compare across sites, putting image from different institutions side by side in the same environment. IIIF is also very powerful for combining and remixing digital content, for instance, the digital rebinding of manuscripts, the digital reconstruction of dispersed objects or collection of objects, to create mashups, combining content from different institutions and of different types. So let's see this short video, maybe. One example of that is the digital reconstruction of a mutilated manuscript whose miniature have been cut out in the past. So you can virtually reconstruct the original manuscript by repositioning the miniature on top of the whole, and the two images come from two different repositories. You can also transcribe materials and generate portable transcriptions that can be easily shared between applications. So here you have only the from the page interface, but thanks to IIIF, you could very easily export the images and the transcribed text that you see here in another client, in another application. You can also annotate content to teach something, or to guide and tell stories to users, or even to crowdsource information. So now let's dive a little bit into the functioning details of IIIF. So the technical framework of IIIF relies on shared specifications that define web APIs, and there are two core APIs in IIIF. First, the image API, which provides a standardized way to request and deliver images on the web. And this is partly used to standardize deep zoom, for example. And second, you have the presentation API, which provides metadata to drive a remote viewing experience, and we'll see that in a second. So if you take a IIIF viewer like Mirador, highlighted in blue, you have what relates to the image API, that is to say pixels, like the image derivatives for thumbnails at the bottom, and image styles and for the deep zoom view at the center. And all these pixels are retrieved by the client by making image API requests to a IIIF image server. And on the other hand, in red, you have what is handled by the presentation API, that is to say everything around the pixels, around the images. For instance, the ordered sequence of views that make up the object, descriptive metadata about this object, rights and licensing information, or the internal structure of the object being viewed. So this applies to images, but it also works for audio content, like in this client, which is the universal viewer. So you have the metadata on the right and the different chapters of the audio recording on the left. And of course, it's the same principles for videos as well, including when you have a series of video sequences, like in this example from Northwestern University. So speaking of AV materials, we should notice that there is no AV API in IIIF. So there is no equivalent to an image API for audio and video. You can just use a regular static audio or video files, or even HTTP-based adaptive bitrate streaming, which are both natively handled by the web browser. So you don't need a specific server to deliver the audio or video materials. The presentation API also brings interoperable annotation capabilities, like annotations onto an image, like in this example from in Mirador, where you see the annotation panel on the left and the bounding boxes on the annotated regions. You can also annotate an audio file, and here you see the annotation associated with the first temporal segment of the audio, and the same capability for a video file, once again in Mirador. So to sum up, the presentation API can be described as a model for presenting and annotating digitized physical objects and born digital content as well. And it provides a standardized description of the structure, layout, and presentation mode of compound digital objects. And it's all based on open standards. First, the shared canvas data model that we'll see in a minute, the JSON-LD format, so JSON for linked data, and the web annotation data model. So one of the core concepts of the presentation API is the IIIF manifest. So it's actually the main unit of distribution in the IIIF universe, like a digital envelope for content. And this manifest is always serialized as a JSON-LD file. And this is this file that will be requested and used by clients for rendering content to users. And all the examples that we've seen before rely in the background on a IIIF manifest. And a manifest is made up of canvases, and the canvas is actually the other core concept of the presentation API, which can be illustrated by a figure like this. So on the left, you have a canvas, which is like a virtual container, an abstract space onto which we paint content, just like PowerPoint, where you have a blank space at the beginning and that you fill with content. It could be text, it could be images, it could be video or shapes, etc. So basically, a canvas provides a two-dimensional coordinate space to associate content with that canvas or part of that canvas. And on the right, you have the digital image itself that is associated to the entire canvas via an annotation in the middle. So in this case, the image is the body of the annotation and the canvas is its target. So in the IIIF model, the canvas is always the target of an annotation, and the body can be any kind of media or resource, text, image, sound, video, etc. So here is another representation to illustrate this very principle. So the canvas has width and height and has the same aspect ratio as the image on the right. And the image is positioned starting at the top left-hand corner of the canvas, so at coordinates 0, 0, 0. But you can have a second image annotation targeting a specific region of the same canvas based on X, Y, W, H coordinates, and a text annotation as well following the same coordinate system. It could be a comment, it could be a tag, a URL, it could be transcribed text, it could be OCR, etc. And you have exactly the same paradigm for video content. You just need a third dimension for the duration, represented here by the t-axis at the bottom, starting at 0. And of course, you can also add annotation which target a particular region of the video canvas at a particular point or range of time. And you could have the same for audio, the only difference being that the canvas will have no dimensions, but only a duration in seconds. So this is, in a nutshell, what the model behind the presentation API provides. And again, all the examples that we've seen in this presentation are actually modeled like that, with a IIIF manifest containing canvases and content resources associated with each canvas, all of or part of it. So there are 4 other APIs in the IIIF framework, but I won't present them today for lack of time, and I also don't think it would be really relevant to this topic, to the topic of this conference. So for the last part of my talk, I'd like to outline one of the main areas of development of IIIF over the next few years, that is to say IIIF and 3D. So this initiative is led by a technical specification group whose main goal is to extend the actual IIIF specifications to support 3D objects, and thus enable interoperable 3D models for viewing and annotating in the same way as it is for 2D images and AV content, as we have just seen. So this work is based on several use cases, like the display of multiple 3D media in a shared space, the ability to annotate 3D media in a common way, or to combine 3D with images and AV content in a single viewing experience. And to do that, one of the changes currently under consideration in the community is to introduce a new concept of scene, which, unlike the actual canvas, would be a boundless 3-dimensional space where 3D models would be placed by using a right-handed coordinate system and by means of an annotation, just like the other types of media that can be associated with a 2D canvas in the example that we've seen before. So in the end, defining a common model for the presentation of 3D media would allow interoperability between viewers, like the Google Model Viewer or Sketchfab, for instance, to be able to annotate a model in any application and view the created annotations in any other compatible viewer. So you could create a standardized guided viewing within a 3D model using annotations, or simply display a 3D model specifying position, orientation, and scale in the same way in 2 different viewers. Or even to combine IIIF images, video, and 3D in a single space, like in this infinite canvas experiment developed by Ed Silverton. So this is the end of this presentation. I just have a final slide to credit a few people from whom I borrowed a few slides and examples in this presentation to be perfectly transparent. So thank you very much for your attention.
We'll turn it over for questions. And while, oh, perfect. Please jump in, please. Yes, thank you.
Thank you, Régis, for the presentation. I have a question concerning the last part of your presentation, concerning the 3D. Does the work group on the 3D is working on a sort of image API for 3D, or only on presentation as already is on video and audio?
No, I think the reflection is only on the presentation of 3D object, and the idea is just to point to a 3D model, whatever the format, in a IIIF manifest. So it's just about the presentation of 3D media and how to combine them together and to mix with other types of media like 2D images and even audio or video content.
Régis, thank you very much. We've been thinking about that 3D problem because we do motion capture, 3D motion capture, and then we play it back. We often just view it in a viewer without any real processing, clean it up a little bit. And the only way we've been able to annotate it is to port it out to a 2D video and then annotate the video. So we've been wondering about how we can get inside the 3D image. But I think it might relate to your question a little bit, whether if it's only presentation to viewers, what happens to something like a motion capture, just a stream of data that we're looking at in a motion capture viewer at the first stage. Do you see any possibilities to annotate that kind of material?
I think I don't know.
Okay.
I'm sorry.
No worries, no worries. I think it's a challenge.
Sorry.
That's right.
Seems like an open opportunity. We will, in the back, yes.
Yes, I think it's partially the same and also about 3D. And in this case, the annotation, are you trying to implement hotspot annotation, or are you actually trying to create somehow having annotation on a surface? So if you think about architectural model, there is a huge difference between what you can say about a plane or just putting an hotspot or something.
I'm sorry, I didn't get the question
yeah, so
precisely.
Yes, I can try to reformulate. So the annotation in the 3D model that you are trying to add are going to be just point, or are actually going to be more complex and following up the 3D surface of the model?
The only example that I've seen are about hotspots. But I think it would be possible in the presentation API to handle the duration. If the scene has a duration, the annotation could be positioned in time as well. But I think you can annotate with shapes as well as hotspots if you have the right coordinate system and a standardized way to point to different coordinates. I think it will be totally possible to have an annotation that target not only a point but like a cloud of point. I don't know.
Well, maybe I can reframe it a bit. In that is, it sounds like this is a new area of IIIF, which is super exciting. And is there like an opportunity for folks in this group to be a part of a working group that's thinking about that question? Because it sounds like there's some exciting or different kinds of needs for this new area. Is there a way for people to get involved in this new area of IIIF?
Yes, sure. I mentioned the technical specification group for the 3D, but it's very much focused on the technical work, but you also have a community group for 3D, which is more dedicated to collect use cases, and this may be the starting point to engage.
Seems like a perfect connection for being in this group today. So, yes.
I was wondering, because there is a lot of IIIF documents already on the web, but it's not very easy to find them unless you know where they are. And I don't know if there is any improvement about searching solutions for IIIF documents on the web.
Could be a long answer, but there is no. The IIIF APIs and the IIIF community is not interested and not focused on the discoverability aspects of things. So it's all about metadata, and metadata metadata harmonization and it's not the point of the IIIF community to solve this metadata interoperability problems. So no, there are probably there will you will never have a search engine for IIIF objects because yes, it's all about metadata and it's up to the institutions to solve those challenges.
Yeah, but so this is the point of view of institutions publishing their content. But for researchers who want to play with the IIIF documents and to study them and to annotate them, it would be really, really useful, even for pedagogical uses or students, or even because as a user, for example, if you look at Gallica, you even never notice that this is IIIF and that you would have so much possibilities to use these documents in this format. So I was wondering if there would be a way to have more connection, more possible connections between the publication of the manifest and then the uses by the researchers, and not only to publish the document on the web.
I think there are different problems, and one of the problem is how the institution advertise that they are IIIF compatible, and it's not always clear that that the digital library is compatible with IIIF, and the IIIF logo is not always present, the IIIF manifest URL is not always visible, and so it's like a UI problem in the digital libraries interfaces, and yes.
Yeah, well, I think we're at time here for a second, but I just want to note that it sounds, first off, that was an amazing explanation of IIIF, and if I know if any of you have tried to understand that, this was the clearest I've come to understand, so thank you for that. The second thing, it sounds like we might have the makings of a grant that needs to go in to connect dots across these institutions and researchers, so I'm just going to plant that seed, and if you want to get involved on 3D, come chat with you, and I want to thank you so much for a wonderful presentation. So thank you.
Thank you.